I am sure this dead planet will one day be alive. For decades, we've been told Mars is a dead, dry rock, a rusty fossil of a planet where nothing survives. But what if I told you we're on the brink, with real tech breakthroughs in 2026 that could make humans Martians?
I think that we can probably send a human mission to Mars very, very soon.
Mars isn't just sci-fi, it's our next home. And the facts? They're mind-blowing. Let's launch. You know Mars as the red planet, but it started out blue. It was once Earth's mirror image, covered in vast, deep oceans.
Most of the northern hemisphere of Mars was covered with water to a depth of about 5 miles deep. Mars had a thick atmosphere. Today, Mars has a much thinner atmosphere, and Mars has no liquid water on the surface. So something happened over the evolution of Mars to cause Mars to lose a large percentage of its atmosphere and all the liquid water at the surface. But in the early history of Mars, Mars looked like the Earth, with liquid water in the form of oceans, rivers, and lakes. And we know that on Earth, very soon after it formed, about 800 million years after the Earth formed, 4.6 billion years ago, 800 million years, we have evidence of the first life forms on Earth.
Getting to Mars is not a weekend trip. The average distance is 140 million miles. That's like circling Earth 5,600 times. A one-way journey takes 6 to 9 months, depending on planetary alignment.
Getting to Mars takes about 8 months one way, 8 months to get back. Each way they'll travel about 250 million miles.
It is not like going to the moon, of course. Traveling to the moon is easier.
The moon is 240,000 miles away. We can go to the moon in 1.5 days and get back in a 1.5 day time period. When we talk about Mars, we're talking about long-term mission. One of the things that we have to do is before humans are sent to Mars, we have to make sure that the infrastructure is on Mars.
SpaceX is planning uncrewed Starship flights to Mars in 2029. NASA aims for crewed orbits around Mars in the 2030s. But there are challenges. Challenge 1 is cosmic radiation. Without Earth's magnetic field, astronauts face cancer risks from solar flares, up to 700 times Earth's exposure on the surface. To solve this problem, NASA and SpaceX are applying different but complementary philosophies. SpaceX is primarily focused on minimizing time in space, while NASA is focused on shielding materials and surface habitats using Martian resources. The most effective radiation shield is simply spending less time in deep space. By refilling Starship in Earth orbit, the ship leaves with a full tank. This allows it to burn engines longer and harder, cutting the trip down to 3 to 4 months. This effectively cuts the crew's radiation dose in half. During a sudden solar flare, the crew would retreat to a designated shelter in the center of the ship. This safe room would be surrounded by the ship's water reserves, food storage, and even waste containers. Water is rich in hydrogen and an excellent radiation blocker.
You're going in a spacecraft. There's intense radiation in space. There's cosmic rays. There's solar radiation. There is solar particle radiation called solar wind. There's the possibility of a micrometeorite the size of a grain of sand hitting your capsule and depressurizing it. There are all sorts of dangerous things that can happen on an 8-month, 250 million mile trip to Mars. Fortunately, there are many people who would like to go into space, that would like to go to Mars for the benefit of human knowledge and human understanding. We'll find out a lot about Mars.
Microgravity wrecks your body. Muscle atrophy, bone loss up to 1% per month, even vision issues. Fixes include onboard centrifuges for artificial gravity and exercise rigs, tested on ISS. Mars's thin atmosphere makes parachutes tricky. It's like slamming into a wall at 13,000 miles per hour. Enter retropropulsion. Rockets fire to slow descent, as proven by Perseverance in 2021. But for humans, we need pinpoint accuracy to avoid craters. Fuel? Hauling it all from Earth is impossible, too heavy. In situ resource utilization, ISRU, is key, making fuel from Martian resources on site. And psychologically, isolation for years could drive you nuts. Think cabin fever on steroids. NASA's simulating this with high seas missions in Hawaii, training crews for the mental grind. Mars days are 24.6 hours, jet lag from hell. But solutions like LED lighting mimic Earth cycles. The holy grail for life on Mars is water. Recent 2026 findings blow the mind. Evidence suggests an ancient ocean covered half the planet, size of today's Arctic, 3 billion years ago. Thin ice sheets may have protected ancient lakes, keeping liquid water stable even in freezing temps. Massive underground reservoirs are enough to flood the surface 1 to 2 miles deep if extracted. But it's buried 7 to 12 miles down, too deep for easy access yet. Polar ice caps hold frozen water. Perseverance found hydrated minerals in Jezero crater, hinting at past rivers.
At that time, 800 million years after the planets formed, Mars looked like the Earth. So you could make a good case that since Mars had liquid water and Mars had a thick atmosphere, that maybe the same process occurred on Mars that occurred on Earth. Life was formed. If we find life outside the Earth, we can learn more about the evolution of life on our planet. We can learn more about the differences and similarities between life that formed in two different places. It will be a big, important discovery to better understand human diseases, how you combat human diseases, and how you understand life processes.
A study from University of Strathclyde explores drilling tech for future missions. Think microwave extractors or robotic miners. According to this method, turning ice into water on Mars requires heat. There are 3 main ways to get that energy. First, direct heat, in which a drill with a built-in heater could be used. The second one is blasting the ice with energy from the surface using microwaves or concentrated lasers. The last one is thermal mining, which is a clever method where mirrors are being used to focus sunlight into a powerful beam to melt the ice. It's perfect for ice that is close to the surface. Mars water is briny, full of perchlorates. Toxic, but purifiable. Without it, no drinking, no farming, no rocket fuel. This is why robotic probes are scouting prime water sites. Mars's atmosphere is a nightmare. It is full of carbon dioxide, 95%. Just 0.6% Earth's pressure, thinner than Everest's peak. No breathable air, and it strips heat fast. Temperatures drop to minus 27 degrees Celsius nightly. But NASA's MOXIE on Perseverance zapped carbon dioxide into oxygen via electrolysis. It produced 122 grams total, enough for a dog to breathe 10 hours. Mars has no global magnetic field, which means solar wind erodes the air. The red planet lost its thick atmosphere millions of years ago. Pressurized habitats or terraforming dreams, like releasing greenhouse gases, could be the solution. Dust storms on Mars block the sun for months, crippling solar power. Hybrids with nuclear reactors are the fix. SpaceX leads with Starship, 404 feet tall, reusable, aiming for Mars city of 1 million by 2050. Elon Musk aims to see established self-sustaining colonies on Mars before he dies.
To a large extent, it's a budgetary question. It's how much money we can get to spend to do it in 10 years. But I think the technology is there. I think the launch vehicles are there. Our understanding, the architecture is there. If we set our mind to it and get the money that we need to do it, we can do it 10 years from now in 2035. I don't know whether we will do it because of the budget and because of the political environment. But yes, I think we have the capabilities to do it, certainly within the next 10 years.
Blue Origin is focusing on New Glenn's bigger variant for heavy lifts, rivaling SpaceX. It is Moon first, but Mars capable. Boeing's SLS for NASA's Artemis is key for Mars preparation. Rocket Lab is there for small payloads, and China's Long March for rival missions. SpaceX Starship could cut costs to $10 per kilogram to Mars. It is definitely a game changer from $100,000 per kilogram today. Establishing colonies on Mars brings many challenges, but Earthlings could still thrive on Mars. Possibility is high.
Before the humans can be launched to go to Mars, we have to make sure that there's infrastructure for the humans. The strategy will be to have 2 cargo ships, each carrying over 100 tons of material, including food and water, a habitat, a roving vehicle so they can get around Mars. That has to precede the astronauts. Then we can send a human mission and the infrastructure will be there.
What's very interesting is that in the history of space research, there has been only one attempt to look for life on Mars using biological equipment, and that was 49 years ago.
49 years ago, NASA sent 2 identical spacecraft to Mars, Viking 1 and Viking 2. I came to NASA to work on the Viking Project. The Viking Project was developed and managed at the NASA Langley Research Center in Hampton, Virginia. My job was to develop computer models of the upper atmosphere of Mars used for entry, descent, and landing. On July 20th, 1976, successfully landed on the surface of Mars, and it became the first spacecraft to successfully land as a working and operational spacecraft. So now when we send humans for Mars, the top priority question will be, is there life on Mars today, or was there life at Mars in the past? We will have a new understanding of the Viking measurements and see if the new measurements and data that the humans take confirm or reject these suggestions.
I accept the fact that Mars travel is daunting, but doable. From water hunts to oxygen factories, we're closer than ever. What do you think? Ready to book a ticket? Thanks for watching. See you on the Red Planet.